Thank you for joining this lesson. I can see people are ready for tonight's broadcast. Remember to introduce yourself. Remember to send greetings to your mathematics teacher tonight. Just say hi to your math teacher. Give me the name of your math teacher. Give me the school that you come from. Give me your name. Lillian from St. Joseph, I recognize you together with all your friends. Invite a friend kindly. If you are in today's lesson and you've not subscribed to Shifting Grades, take this opportunity to be one of the subscribers. Just subscribe. We'll be doing a mathematics paper 1. Allow me to bring the paper to you. The paper is called a Mokasa. This is one of the joint examinations done this term, and we are going to revise the paper. Just be attentive. Invite a friend. Say hi to your math teacher. I'm going to recognize you from where I am. Thank you so much for subscribing. You can see people are really turning up. You can like, you can share. Remember, tomorrow we'll be doing physics paper 2. And I also invite you for tomorrow's lesson. Number 1, express 21,952 and 3136 or 3,136 as a product of the prime factors. Hence, evaluate the cube root of 21,952 divided by the square root of 3136 of 26. So let us approach this question. The first thing will be we express numbers in their prime factors. We start with the 21,952. So now the least prime factor is usually 2. So we take now the number 21,952, we divide it by 2. This gives us a 10,976. The next, we can see it's an even number. So we continue dividing by 2. This gives us 54,88. We divide again by 2. This gives us 27,44. We divide again by 2. This gives us 13,72. We divide again by 2. This gives us 686. We divide again by 2. The number continues. This gives us 343. So now when we take 686 by 2, we are getting 343. And at this point, we can check whether it's now not divisible by 2, because you can see it is not ending with an even number. So when you divide by 3, it's not going. So you can divide this by the next prime number, which is, I think, 7. Yeah, we divide now by 7. This gives us a 49. And we divide by 7 again to get 7. Therefore, we can now express 21,952 as equal to, we count the number of 2's. You can see 1, 2, 3, 4, 5, 6. So 2 power 6. Then we multiply by, the only other prime factor is 7 raised to power 3. We have expressed that number. The next number is 3136. We are also going to express it as a product of its prime numbers. So now we write 3136. We start again by 2, the least prime factor. 3136 by 2. This gives us 1568. We divide by 2. This gives us 784. We divide by 2. This gives us 392. We continue dividing by 2. When you divide by 2, this giving me 196. We divide again by 2. This gives us 98. We continue dividing 98 by 2. This gives me 49. Then now by 7, we get 7. Therefore, if this number is expressed as a product of its prime factors, we shall have 3,136 becoming what? We count the number of 2's. 1, 2, 3, 4, 5, 6. So 2 power 6 multiplied by 7 power 2. Now we go to the other part of the question. We are evaluating the cube root. The cube root of the first number. Therefore, we want to obtain the cube root. Remember, to extract cube root of a number, we can just multiply, or we can just raise to power a third. Instead of root 3, we can have it as power a third, such that we have 2, 6 multiplied by 7 power 3. This one now can be raised to power a third. That is another interpretation of the third root, or rather cube root. This one is being divided by, this one divided by the square root of 2 power 6 multiplied by 7 power 2. This one, because we are taking square root, we can multiply by, or we can raise to power half. In such a case, now we apply the product law of indices, whereby, okay, there is another number there, which is when you see the word of, it means multiplication by 26 now. When we apply the product law of indices, you discover that in the numerator, 2 is becoming power. When 6 is multiplied by a third, 2 will be power 2. Then 7 is multiplied by, or is raised to power 1, 3 times a third. Then this is divided by, we multiply through by half, so that 2 is now power 3, because 6 times half becomes 3. Then 7 is now power 1. This one multiplied by 26. We can finish up now by combining. When we have 2, when you have 2 divided by 2 power 2 divided by 2 power 3, this can be 2 power 2 can cancel, such that this becomes 2 power 1. So we are having a 7 cancelling, because 7 is power 1, and in the denominator it's also power 1. So what we are having is now 26 out of 2 power 1, which is just 26 over 2, and this will finally give us the final answer is 13. So the final answer in this case is going to be 13. Continue subscribing. Continue inviting friends. Yeah, continue inviting friends. I can see you are increasing. This number is good. Invite someone. Invite someone. Somebody says, I love your work. Representing Concord Boys High School, Eldoret. Thank you so much. Tag your teacher from Nakuru Daystar represented. Wonderful. This is great. This is great. Kisumu girls. Kisumu girls, I see you. Madam Solomon Matungulu Boys, wonderful. Kisumu girls. Wow, I recognize your presence. Njoro girls, wonderful. Migwani Boys represented. Ukia girls, I see you. Thank you so much. Invite all your friends. Make sure you learn with a friend, please. Invite someone tonight. Invite someone tonight. St. Joseph, I recognize you. Kipsigis girls, this is great. This is great. Let us invite our classmates and our friends from different places. Number 2, a very good question, very interesting. We are going to enjoy this one. The question says that the LCM and GCD of three numbers are 7,560 and 18 respectively. If two of the numbers are 360 and 540, find the least possible value of the third number. Find the least possible value of the third number. Okay, there can be very many approaches to this question, but I recommend people to use the factorization method. Just factorize everything which has been provided in this question. For example, to factorize, we can begin with the LCM, then the GCD, then you also factorize all the other numbers. The numbers which have been provided. Let me show you how I'm going to do it. I will draw a simple table here showing every number expressed in prime factors. Number 1 is involving prime factors. Number 2 is also involving prime factors. So let's see the least possible number. Let us see. The numbers can be many, but the examiner is specific. They want the least possible number. So we are going to write our prime factors. Our prime factors here, so that we outline the numbers which have been provided and any other possible number which might arise when you are handling such a question. Because sometimes the question can be open, you can be told to find other possible numbers. But in this case, the examiner is very categorical. We are being asked to find the least. The least. Bahati girls, Kisumu girls, Kisumu girls. Wow, this is Buruburu girls. Wonderful, wonderful. Mr. Patrick, I send greetings to your mathematics teachers. Sironga girls. Maweni from Mombasa, wonderful. Good work, Mwalimu. Thank you, teacher. This is wonderful. The Machakos School. Great work. Thank you, Machakos boys. Continue following. Those are my boys. Whenever I'm not online, those are the people that I teach practically at Machakos. That is great. That is great. Continue following. Miss Nzomo Kitondo School. Wonderful. Bahati girls. St. Joseph Raponki. Ingose High School. Kakamega. Great work. Let's do it now. We are going to factorize 7560. 7560. So when I take 7560 now, I will just start dividing it by 2. So that I can say 2 goes once. Then we can also divide by 2 again. So that I can say there's another 2. I again divide by 2. So 2 is to power 3. The other prime factor now can be 3. So we divide by 3 times. When I divide again by 3, I get 105. I divide again by 3, I'm getting 35. So that now I have 5 and 7. So this number now will have 3, also power 3, and 5, power 1, then 7. Those are the prime numbers for the LCM. What about for the GCD, which is just 18? We can have 2 to get 9. So 2 will be power 1. Then after we get 9 now, you split it into 3, which is going to be squared. So 3 is to power 2. We are through with factorizing the GCD. Let's go to the numbers provided. We start with the 360. We factorize 360. We can begin by 2 to get 180. By 2 again to get 90. By 2 again to get 45. So 2 is to power 3. 2 is to power 3. Then now we divide by 3, we get 15. And by 3 again, we get 5. So this will be 3 squared. 3 squared, then 5. Then 5, like that. 3 squared, then 5. We go to 540. We factorize it also. Let's work with 540 now. We factorize 540. Tonight, everybody must understand. Remember to stay around for only 1 hour. 540. Now to factorize. By 2, we get 270. By 2, 270 over 2 must be, is it 135? Yeah. By 235. So that now we go to 3. Such that it becomes 40, sorry. It becomes 45. And by 3 again, we will be at 15. Then by 3, we get 5. So now we'll be having 2 squared, 3 power 3. 2 squared, 3 is power 3. And 5 is power 1. Let us now start looking for the other possible number, such that the LCM and the GCD are going to align with the ones provided. Brighton Ngoto boys, I recognize you. Wonderful. Okay, the LCM and the GCD are up to this point. They are up to this point. Let me underline that. They are up to this point. Now the other numbers begin there. We can let the number be x. Now the number is supposed to have the factors which we can see around, but we should know that it should be such that when all the numbers are factorized, they give us the LCM and the GCD that we have. So in case the numbers are provided, they should be having 2 power 3 and at least 2 power 1. According to the LCM and the GCD, the number should be having at most 2 power 3 and at least 2. This means the number which is coming in, for it to be sharing the GCD, it should at least have 2. At least have 2, because if you start factorizing them, 360 will provide 2 power 3. So we just want minimally the 2 to appear so that they may share the GCD. When we go to the next factor, which is 3, the greatest power of 3, according to the LCM, should be 3 power 3. And according to the numbers which have been provided, 540 has already given us 3 power 3. Therefore, the number which is coming in for the purposes of the GCD, it should be having a minimum of 3 power 2. A minimum of 3 power 2, so that it shares the GCD, because when we factorize it, it should give us 3 power 2, at least 3 power 2. At least 3 power 2. When we go to 5, the 5 is not a requirement for the GCD. We should know that. You can see for the GCD, there is a gap here. There is no 5. Therefore, the numbers which are coming in, they are supposed to give us 5 for purposes of the LCM. But when we look at 360, together with 540, they have already given us the 5. So because it is not required for the GCD, it is also not very necessary for the number which is coming in. Though, yeah, it is not even very necessary. It is not supposed to be there, because if it is there, the 3 numbers will start having 5 and the LCM will be tempered with. Therefore, to ensure that the GCD will be tempered with, to ensure that the GCD remains 18, then the number which is coming should not have 5, like the ones which have already been factorized. Because if it will start containing 5, then we will be required to change the GCD. So 5, we leave it a gap. When we go to 7, the last factor, now we tell ourselves that the other numbers are not giving us 7, and the GCD is okay because it's not having a 7. But now we have a gap here, and a gap here. But now for the LCM to remain, at least one of the numbers must be having the factor 7, yet the ones which we have already factorized, none of them is having 7. So this can now take up the 7. This can take up 7. Remember to like our lessons. Remember to invite a friend. Remember to subscribe kindly. Remember to subscribe. All right. Now the number minimally, though there can be other numbers, the minimum ones is going to be now 2, 3 power 2 multiplied by 7. Therefore, this is going to be 2 times 9. 2 times 9 will give us 18, then times 7. This will give us 126. Yeah, 2 by 9 by 7, 126. So the number is 126. There can be other numbers now, but this one remains to be the least. People are still following. Somebody is saying number 2, there is an alternative way. Yeah, it's true, there are alternative ways, but what I have showed you is the best way that will help you to get the minimum number. You can get other possible numbers, and you are required to use those other alternatives. But for minimum number, kindly adopt. Precious Jerry from Kisumu, thank you. Nep Girls High, wonderful. Somebody is saying we concentrate, and that is okay. Thank you, Kitondo School. I still recognize you. I remember yesterday night you really contributed. That is wonderful. Number 3, without using a calculator, evaluate. Without using a calculator, evaluate. We have 0.3, but on top of 3, we can see a dot, which means recurring. Then plus 0.15, that means the 5 is recurring, depending or according to how the dot has been placed. Then we have 0.6, and 6 is recurring. We are supposed to first of all convert these fractions, this into fractions. So let's make them fractions. The first one is, we can let it to be R, 0.3, and the 3 is recurring. Then we go to the next, 10 times R, whereby it becomes 3.333. We should continue until the decimal part can be subtracted to give us 000. And so far we are okay. So when you subtract upwards, you shall get 9R equals to 3. So the value of R will be 3/9, meaning 1 out of 3 after simplification. The next one is a 0. Let's convert all of them first. 0.3 is going to be our R. So we start with writing R. 0.15, sorry. R is 0.15. So it is the 5 which is recurring. It is the 5 which is recurring. So we can say 10R is equivalent to 1.555. At that point, if you subtract the decimals part, you will not get 00. So you continue 100R. This shall be 15.555. So we can see if we subtract the second and the third, we can get 00 on the decimals part. And so we can start now subtracting. When you subtract, the R part is going to give us a 90R. equals to 15 minus 1, which shall be 14. So R is going to be 14 out of 90. This shall be 7 over 45 when you divide by 2. 7 out of 45. I know you know how to convert recurring decimals into fractions. We continue. The last one is 0.6. So R equals to 0.666 recurring. So that 10R becomes 6.666. So now they can be subtracted to give 0 on the decimals part. So we need to talk about 9R now, equivalent to exactly 6. So R shall be 6 out of 9. This can simplify to by 3, 2, by 3, 3. It can simplify to 2/3. Now we get back to the expression here, whereby 0.3 is a third plus 0.15 is 7 over 45 divided by 2/3. Divided by 2/3. So the first case, we can get a third. Okay, we are told without a calculator anyway. Let's not use a calculator. The LCM shall be 45. Yeah, the LCM shall be 45. So 45 divided by 3 is 15 times 1, it remains 15, plus 45 by 45 remains 1, then by 7 we get 45. So this we get 7, that is. So this is going to be 22 over 45. 22 out of 45 divided by 2/3. When you divide by 2/3, it's another way. Dividing by 2/3 means multiplying by 3 over 2. Dividing by 2/3 means times 3 over 2. So we can have by 2, 1, by 2, 11, by 3, 1, by 3, 15. So that we have 11 out of 15 as the final answer. 11 divided by 15. This becomes the final answer. This is what you shall submit now to your teacher. The questions today are a bit involving, and you are going to bear with us until we finish. I can see you people are inviting friends. I can even see that you are greatly subscribing, and that is wonderful. Please continue subscribing. Continue subscribing. Continue sharing the link with friends. Continue sharing your links with a friend. Our number is already on the screen. Continue liking our videos. Brother Nicholas High School, Busia. Wonderful. Wonderful, wonderful. Now, the next question. We go to the next question. Remember, I cannot, Nyabururu girls, I cannot manage to recognize everybody. Just know that I'm grateful to everyone, and I really like what you are doing around. Remember to invite a friend. Remember to invite a friend. All right. I believe you've copied down the question. After this presentation, the video will remain in YouTube, so you can follow it again and again. You can even reteach yourself now. You get back to the videos and you see where you did not understand. You re-listen again. Yes. Number 4, solve using tables and square roots. Tables of square roots, sorry, and reciprocals to the nearest 4 significant figures. To the nearest 4 significant figures. Therefore, I'm going to open the math table so that we may read the reciprocals of these numbers. Remember, we are first of all going to carry out square roots. Therefore, the first thing we are doing in this is to write the number whose square root is being determined. We write it in standard form. Therefore, we write 0. You can see the number You can see the number here. Yeah, 0.02548 in standard form. So this number shall be in standard form. In standard form, it shall become 0.025. So we start with 2.548 10 to the power of -2. This is the number whose square root is being determined. This is the number whose square root is being determined. This is the number whose square root is being determined. Therefore, we can read the first part from the maths table. Let's read the first part from the mathematical table. I can see we are 277. Let us invite people. We can be even 300 in this class. We can go to 300 in this class. And tomorrow we purpose to be 500. Invite someone. We read now the square root of 2.5. Then we go to 4 and we add what will be on the column for 8. So 2.5 from the mathematics table, we go to square roots for 2.5. Yeah, 2.5 is here. 2.5. Then we go where there is what? 4. We go where there is 4. This is the column. So we go down that column now. Going down that column, we shall find ourselves here. So that will be 1.5937. 1.5937. 1.5937. Then we add what is in the column for 8. On the differences, on the addition sign, where there is 8, we check the column there. Where there is 8, we go down that column until we intersect here. And we are finding a 25 there. What I'm finding here is a 25. Is that so? Yeah, 25. I can see a 25. So I hope you can see my screen, 25. So now at this point, when you add from the right-hand side, I'm getting 2. Carry 1, I'm getting 6. Then 9, 5.1. This is now the square root. But for the 10 power -2, because it is an even power of 10, now we shall multiply by 10 power -1. 10 power -1. So when you multiply by 10 power -1, now that is the final square root, though it can be written as a number 0. Instead of standard form 15962. I'm leaving it at this point because I still want to use it for calculation of a reciprocal. So I have to write again in standard form. That is why I didn't want to finish up. But now at this point, we will say 38.21. This one is being divided by 0.15962. So for us to find the reciprocal now, we should factor out 38.21. So that we deal with the reciprocal now. Reciprocal, we remain with 1 on the denominator, on the numerator. Then the numerator, the denominator can now be written in standard form 1.5962, and we multiply this by 10 power -1. We can now read from maths tables what we are calling the reciprocal of 1.5. And because we can only deal with 4 significant figures, then we'll be talking about 1.5. We go to the column of 9, then that of 6. This will be 1.596. This is what we are going to the table of reciprocals with. 1.5. So the table of reciprocals. 1.5. Yeah, this is it. 1.5. 1.5 is here. Then we go to where there is 9. Where there is 9 is here. So we go down that column. This is where we are. 0.6289. 0.6289. So we have 0. Let me work it out here. 0.6289. Then now on the differences side, we subtract what is in the column of 6. So in the column of 6 now, we go down there until we find 25. For reciprocals, it must be known that this is subtract, not like the other tables. So we are subtracting 25. So we subtract 25 at the end here. 25. So we're going to have 4. This will be 6, 2, 6, and a 0. So this is now the reciprocal. The reciprocal is going to be 0.6264 multiplied by the reciprocal of this part now, 10 power negative 1. The reciprocal of that part becomes 10 power. You just reverse the sign of that power. It becomes 10 power 1. The reciprocal of 10 power negative 1 is 10 power 1. If it was 10 power negative 2, it would have been 10 squared. So the reciprocal of 10 power negative 1 is 10 power 1. We are winding up with this question, 38.21. Then this is going to be 6.264. And this is finally going to give us, when we take 38.21 multiplied by 6.264, I'm getting a 239.35. But remember, the instructions are 4 significant figures. So up to the 4th significant figure, it should be 239.4. That is the 4th significant figure. Yes. Thank you so much. I can see you are still around, actively following, actively contributing. Wonderful, wonderful, wonderful. Let's continue. Thank you, thank you, thank you so much. All right, remember to subscribe. Remember to subscribe. Our number is on the screen. Our number is on the screen. You can make good use of the number on the screen. Make good use of the number which is on the screen. Thank you so much for the continued cooperation. Let's look at number 5. Simplify the expression 49x squared minus y squared divided by 21x squared plus 35x minus 3yx minus 5ya. Let's now simplify. In the first case, for the numerator, let's do the numerator. The numerator is the difference of 2 squares. So for us to factorize the difference of 2 squares, we need the square root of the first term, 7x. Then we subtract the square root of the second term, which is y. It's y squared, so we get y in brackets, then 7x plus y. The first case is now settled. We are through with factorizing a difference of 2 squares. You just imply that we call it a quadratic identity, whereby we factorize a difference of 2 squares, one touch. Just that way. Let's look at the denominator now. Remember, we know what we have gotten. We know what we have gotten from the numerator. So now when we are going to the denominator, we factorize it with reference with what we've gotten. When we look at the first terms, the first 2 terms, 21x squared plus 35ax, then minus 3yx minus 5ya. In the first 2 terms, there is a common factor, which is x. When we factorize x, we shall remain with 21x and 35a in the brackets. When we factorize in the second case, we are having a 3yx minus 5ya. Minus 5ya. So you can see, again, the common factor there will be y, and we will remain with 3 minus 5, which means such a factorization will not favor the numerator. And so we can make a sober judgment of swapping some of the terms, like having the numerator at the denominator becoming 21x squared. Instead of starting with 35, we can even start with 3y, 3yx. Then we add 35ax minus 5ya. I've just swapped the middle terms. I've swapped the middle terms so that when I'm factorizing now, like I factorize 3x in the first two terms, I'll remain with 7x minus y. Then plus the common term here, or the common factor, will be 5a, so that I remain with 7x minus y. So you can see now this order is favoring the numerator that we already have. And so we can have the common part, 7x minus y. Then we have 3x plus 5a. At this point now, we can combine the numerator and the denominator. We just combine the numerator and the denominator. The numerator and the denominator. We are almost 300. I can see 286 people following us. This is great. This is great. We are going there. We are almost there. Invite somebody, subscribe to this lesson, share our link. Remember to invite someone. So now the numerator is 7x minus y. Then we have a 7x plus y. This one is now being divided by 7x minus y. Then 3x plus 5a. Now, when you look at these factors now, in the numerator, this factor is the same as this. And so we can now simplify to 7x plus y divided by 3x plus 5a. So I think you've learned something there. There was a big trick in the arrangement of the terms in our denominator here. So that is how you are supposed to go about it. That is how you are supposed to go about it. Number 6, a word problem, which says that number 2 was demand. Okay. All right. Let us be serious. We are in number 6 now. A 2-digit number is such that the sum of its digits is 11. When the digits are interchanged, the original number exceeds the new number by 9. Find the original number. This is a very good question. Thank you. I see you are inviting people. We are now 298. Invite someone to run with us. Let us go together. Kindly. Okay. Now we are talking of a 2-digit number such that the sum of its digits is 11. So we can just come up with a simple equation. We can let the number to be xy, so that when we are talking of sum of the digits, we say now x plus y is equivalent to 11. This is our first equation. When we continue interpreting, you discover that when the digits are interchanged, so to interchange the digit, it means now it becomes xy. Now, the value of this number is now differing with what it was initially, because we are told the original number exceeds the new number by 9. So we can look at the total value of the new number. Total value of new number, it's going to be 10y, because y is in the tens and x has gone to ones. So it is a 10y plus x. Again, we can talk of total value of the original number. Total value of original number, because it is xy, it's 10x plus y. Remember, the total value of the number, if a number is 42, for example, the value of this number, because 4 is in the tens, this number is 4 times 10, and 2, which is in ones, 2 has been multiplied by 1. That is why the number is totaling to 42, just for an example. So in these numbers, the total value of the new number after you reverse yx, it means it's 10y plus x. The original number was 10x plus y. The examiner is telling us the original number exceeds the new. So the original number, 10x plus y, it exceeds the new number by 9. So when we subtract the new number, remember to open brackets here because you are subtracting, we are supposed to get 9. So this is 10x. We group like terms together. 10x plus y minus 10y minus x, because of the brackets you are opening, equals to 9. Equals to 9. Grouping like terms together will give us a 9x minus 9y equals to 9. This is the second equation, which can be simplified further because 9 is common all through. X minus y equals to 1, our second equation. Now we have the second equation and the first equation. These are the equations that we are supposed to solve simultaneously. These are the equations that we are supposed to solve simultaneously to get our number. So we can say from equation 1, remember, I want everybody to understand now. Remember, methods of solving simultaneous equations are even very many. But now we are saying from equation 1, the value of x can be expressed as 11 minus y. We make x the subject of the first expression. And I want to use a substitution. Therefore, because x has been expressed, now we can substitute it in equation 2. Instead of x, I write 11 minus y, then minus y equals to 1. I have rewritten equation 2. Where there is x, I have substituted with 11 minus y. So now we shall say negative 2y, because of negative y minus y equals to 11 minus, 1 minus 11, negative 10. So that the value of y will be, when you divide it through by negative 2, the negative will cancel and we shall have y as 5. With y as 5, the value of x can now be determined such that x is 11 minus 5. So 11 minus y, which is 5, we should get 6. So the number is xy, the original number. The order is xy, so the number should be 65. The number is 65. Exactly 65. Thank you for following. Thank you for turning up. Thank you for being patient. Thank you for inviting people. Thank you for finding it good to subscribe. Thank you for even liking and commenting. Continue being active. Say hi to a friend. We are doing well in this platform. This is your channel. This is simply how you will get an A in mathematics. This is your year. The next question now, we should be in number 7. Our number is still on the screen. Remember to use it. Number 7. We are talking about a Kenyan company received 103,800 sterling pounds. The money was converted in a bank which buys and sells foreign currencies as below, or as follows. So we're having 1 sterling pound, 1 US dollar, the rate in Kenya shillings. Somebody is asking, calculate the amount of money received to the nearest US dollars. It's good for you to know that there is no relationship, according to this bank, there is no direct relationship between the US dollars and the sterling pounds. So the sterling pounds that is coming to the bank as first of all to be converted to Kenya shillings, then from Kenya shillings to another foreign currency now, which is the US dollar. That one has to be understood. So what we do here is to say that from foreign currency, we use these acronyms, foreign currency to Kenyan currency, we use the buying column, and we shall multiply. For that case, we shall multiply from a Kenyan currency to foreign currency. We use the selling column, the for sale, the selling column, and for this case, we usually divide. Therefore, it's good for you to know that the amount in sterling pounds, because it's foreign to Kenyan, we use the buying for sterling pound. So we are here for sterling pound. The bank is buying. The bank is buying. So 103,800 should be multiplied by 145.78, so that you may get Kenya shillings. So this will be Kenya shillings, 103,800 multiplied by 145.78. This is giving us 15 million 131,964 Kenya shillings. Now the total amount is going to be converted now to US dollars. Remember, from Kenya shillings to US dollars, now it's Kenyan currency to foreign currency, whereby we shall use the selling column and we divide. Therefore, we have to take 151,964 divided by the amount in the selling column for US dollars. So for US dollars in the selling column, we have 110.86. This is going to give us, when you divide by 110.86, we are going to get, remember it is to the nearest US dollar, so it should be 136,496 US dollars. US dollars to the nearest US dollar. This is the amount that we are going to receive. This is the amount that we are going to receive. Okay, we continue. Number 8. This is on angle properties. We are told that in the figure below, O is the center of the circle. Then FG is parallel to JH. Just as you can see, there are some arrows there to indicate that the lines are parallel to one another. And angle GJH, so GJH, it's already indicated 26. Calculate the size of the angle FJG. FJG, the angle at this point, FJG. So I want us to solve these angles together. There are some properties of angles which we are supposed to master. Angle properties that we are supposed to master. Some are in Form 3, majority are in Book 2. Angle properties of circles. For instance, because O is the center, then JB is a diameter. And we all know that angles subtended by the diameter at the circumference are usually right angles. They are usually 90 degrees angles. So that is a 90-degree angle because it's an angle subtended at the circumference by a diameter. Something else that we are supposed to know, is that now that we have 90, and for the triangle JGH, we have again 26, then we can get the angle at H. The angle at H can also be obtained. So we need 180, and we subtract 90 and 26. This will give us exactly 64. So this is going to be 64 degrees. 64 degrees. We are still solving it. Kindly continue following. Be very keen. Be very keen. Ni Trevor McBee. Thank you, Machakos School. Thank you, our boys. Continue being around. Continue being around. Just make sure you are there to learn. Remember to subscribe. Somebody is saying that Ngotobo is Ikokin. That is great, Ngotoboys. I recognize you, Jaden, and your friends from Ngotoboys. All right, with 64 at that point, we are supposed to apply another law or another principle, another property, whereby we say opposite angles in a cyclic quadrilateral are usually supplementary. And for that case, we can say that first of all, the quadrilateral, the four-sided figure that you can see, is called a cyclic quadrilateral simply because all the vertices are touching the circumference of the circle. Therefore, opposite angles are supplementary. So the angle 64 with the opposite angle here at F, they should give us 180. So 180 minus 64 will lead us to concluding that the angle at this point is 116. So 116, because opposite angles are usually supplementary. Opposite angles are supplementary. Opposite angles are supplementary. Thank you for following. I'm around to ensure that you are learning. I am around to ensure that you people are reaping the best. You will go home with the best. You will not regret referring a friend to this platform. Refer a friend, they shall also benefit. Finally, let me apply a principle here which is going to help us. We said FG and JH are parallel to one another. That means JG or GJ is acting at a transversal line. And so the angle at this point with the angle of 26 here are called alternate angles. Being alternate angles, they must be equal. So because of the transversal line, we call them alternate angles. With the alternate angle there at 26 and the other angle is 116, then we can say that now inside the triangle FJG, we are supposed to get 180. So we need 180 and we subtract 116 and 26. And this is finally going to give us the value of the angle. Therefore, when we take 180 and we subtract 116 plus 26, we are getting an angle of 38 degrees. So the angle at this point is exactly 38 degrees. The angle there is 38 degrees. Continue using the number on the screen. That is the number we are supposed to use. Number 9, it's on a scale drawing. We have a lot of videos on scale drawing, a lot of them, a lot of videos on scale drawing. And in this case, I'm just going to describe what you will do because I don't have tools which will help me to come up with an actual scale diagram. But once we sketch it together, now during your own time, you can come up with the actual or the real scale diagram, and you shall be in a good position. You shall be in a good position. We are continuing We are continuing. Let me share to somebody also. And you people are wonderful. We are already done with the first 1 hour. Let's wind up. 3 towns A, B, and C are such that B is 50 kilometers on a bearing of 70 degrees from north to south. This is called compass bearing. Compass bearing. From A, and C is 70 kilometers east of B. Use a scale of 1 centimeter to represent 10 kilometers. Draw a diagram to show the relative position of towns A, B, and C. Towns A, B, and C. So for towns A, B, and C, we can start very well because the first reference point is A. You know, we usually start with the first reference point. When you hear the word from, then that is a reference point. You cannot start by identifying B. They are such that B is, so we cannot identify B first. We identify the reference point from A. So it is A, it is from A that now we are going to identify the relative position of B. Therefore, assuming that this is our A, assuming that point A is here, this is our north, then when we turn from north toward the west is usually to your left hand. So compass bearing means from north, 70 degrees towards west. So 70 degrees towards west, you just measure with your protractor, 70 degrees towards west. You produce 70 degrees towards west. Then now through that angle, when you measure a distance of 5, because these are 50 kilometers, the scale is 10, you divide, you get 5 centimeters. So you get 5 centimeters and you get an arc for 5 centimeters. Then upon that arc, because you had measured an angle of 70 to turn, then you are supposed to have another 70 on the lower side. A 70 here, so that the compasses are parallel to one another, and you raise a compass at that point. To identify another 70, you raise a compass. That is our point B. There is another position which has been talked about. We are told that C is 70 to the east of B. East of B means to the right. Therefore, standing at B, you just produce a perpendicular actually, which is horizontal, a perpendicular which is horizontal, and you move for 7 centimeters because of the 70 kilometers. So you just move 7 centimeters. So that once you make an arc for 70 centimeters, you can also raise another perpendicular at that point. You raise another perpendicular at that point. This is our C. Now C can be joined to A. Those are the relative positions. Those are now the relative positions for these places. You can measure angles now. You can measure distances. You have the scale diagram. So this is a good sketch to help you, so that whenever you be drawing the scale diagram, at least you will have somewhere to begin from. Determine the distance of in kilometers of C from A. C from A. So you shall measure in centimeters and you multiply by the scale. Measure in centimeters, then multiply by the scale to get the actual distance. Thank you so much. People are still reading with us, learning. This is great. Let us continue learning. Let us continue learning. I see you, Laventa, from Emmanuel Springs. That is great. Let's invite friends We are almost finishing, you people, don't worry. Number 10. An indices question, number 10. Number 10, solve for x in the equation. Solve for x in the equation. Solve for x in the equation. The equation says that 9 into brackets 2, then power 2x plus 2. You close the brackets, minus 41. Then we have 2 power x plus 8 equals to 0. We can apply some laws of indices in the first term, in which case we are going to say 2 power 2x plus 2 means that this is 2 power 2x multiplied by 2 power 2. Because of this law of indices, we call it the multiplication law of indices, which says if two numbers are raised to given powers, or a number a is raised to power m, then the same number is raised to power n. We can solve this one by taking a and we just add the powers. If this is true, according to the laws of indices, then we can say that this one can be split because it is having two powers which has been added, two powers which have been added, then it can be combined or split to have 2 power 2x and 2 power 2. And now, instead of this, we will have 9 multiplied by 2 power 2x. Then we also multiply by, okay, let me not introduce the bracket there. We multiply by 2 power 2, which is 4. 2 power 2, which is 4. Then minus 41, there is 2 power x plus 8 equivalent to 0. At that point now, allow me to say that times 4 will give me 36. So 36 into 2 power 2x minus 41, 2 power x plus 8 equals to 0. At that point now, we continue applying laws further, whereby we will say that, you know, there is this law of indices, which says that in case the product law of indices now, this is called the multiplication law of indices, and now a multiplication law of indices is here. The product law of indices, which says in case you have a number raised to a power m, then this is now generally raised to power n. We just take a and the product of the powers, the product law of indices, just multiply the powers. That means we can say that this is 36, then 2 power x, which has been squared. I'm just applying the reverse of this. Minus 41, 2 power x plus 8 equals to 0. Because 2 power x is appearing severally, allow me now, let's let 2 power x to be, let's say, a certain unknown like t, just any unknown. So this will be 36, then this will be t squared minus 41